Okay, Andy. So, good morning, everyone. Online friends, can you hear my voice? Say yes or no to me once. Right. So, yesterday's class, let me repeat once what has been happened. Right, for 5 minutes. So, yesterday I started inheritance, the process of interlinking two classes with extends keyword. The process of interlinking two classes with extends keyword and making the members of one class available to another class. We are calling it as inheritance process. So diagrammatically here, I shown one diagram to you. Inheritance. This one. This one. So here one C1 extended to C2 and the members of C1 are available to C2. That is the information here. By terminology, we are calling it as parent class and child class. You can call it as super class and this is subclass. You can call it as base class and derived class. It's a theory. Okay, right. Now, then types of inheritances anyway. How many ways you can interlink the classes? Based on interlinking the classes, inheritances from object-oriented programming languages are categorized majorly into 5 types. Single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance, and hybrid inheritance like this. Yesterday program and diagram comes under single inheritance only because I took C1, I took C2, C1 extended to C2. So the diagram. In your diagrammatical flow also here, in a diagrammatical flow, 1 or 2 points you observed here. The point is, sir, we are creating object for child. In the process of creating object for child, parent class loaded and the child class loaded. The first priority of loading is parent, then child. Both looks like a single class for the execution control. That's the meaning. And one object only created for the two classes. While object creation, parent members will come, then child members will come. That is the behavior. The small execution behaviors will help you. Okay, right. Finally, what are the instance members available in the parent? They all will get the memory within the object of a child. So theory, what are the static members available within the parent? You can access with the child. That's the information to you. That only I demonstrated with the case one. Then I took one small interview question known as overriding process. Overriding means method replacement. The replacing the existing method, we call it as override. The method with the same method signature in parent class and child class. The method with the same method signature in parent class and child class. Then parent class method is replaced by child class method. We call it as method overriding. So same method signature means what? Return types will be same. Method name will be same. Parameter list will be same. Parameter type also will be same. That concept we call it as same method signature. I took one small program, I took it. Diagram I not drawn. Today I'll draw the diagram. Whenever I'm drawing the diagram today it is a revision like yesterday's diagram once, and we are showing the overriding. That's my concept. Okay, right. So today's class starts with small diagrammatical form of your program, demonstrating instance method overriding process. I'm demonstrating. Okay, right. Yesterday's notes I not updated. Now I updated. You work it out. Okay. So execution flow anyway. Right. So in this execution flow, class files. How many class files available? Sir, parent class dot class file, child class dot class file. I took demo inheritance 2 I taken. Demo inheritance 2 dot class file. Demo inheritance 2 dot class file. This is one main class. So see there the diagram. Method area, heap area, Java stack area. The first class loaded is main. So main class loading I'm not drawing. You understood the concept yesterday already. Okay, right. So here I am taking the diagram here. So method area. Where classes are loaded. Heap area where objects are created. Java stack area where methods are executed. Anyway, method area, heap area, Java stack area. Method area, heap area, Java stack area. The main class loaded and main method will come for execution. inheritance application to here parent class, child class, demo inheritance to, like this. In demo inheritance to, this is main method. So main method will come for execution. This main method is coming for execution. In this main method, first line, create object for child. Child class OB equal to new child class. Create object for child. Yesterday given information. In the process of creating object for child, first parent class will be loaded. Parent class will be loaded. Parent class is having one method, that is void m of int x. So here void m of int x. Then the child class will be loaded. Child class will be loaded. So child class will be loaded. Child. Child class loaded. Here to here we had extents. So that's that. Here we had a method, same method, void m of int x. What you observed here now, sir? Here void m int x means return type same, method name same, parameter list means here one, type means int and int. So all are same. So once the loading has been completed, I made a statement to you. This two looks like a single class only, they look. This two looks like a single class. It's a single component only anyway. It's look like a single component. Now once the loading has been completed, object creation starts. Object creation starts. Zero x2 object creation starts. What is the rule of object creation yesterday, sir? First parent members will come. While object creation, first parent members will come, then child members will come. From the parent method will come. Void m of int x. So this is parent method body. This is parent class method. This is parent class method. First parent class method will come. Sir, parent class method key. Once the parent class method came here, then it looks for the child. In the child, same method is there, no? Look here. Example, in your C drive or D drive, example in your hard disk, in D drive, one folder is there, XYZ. In that XYZ, you want to save one file. The file is some image.jpg or image.txt. One file. Already file is there. Again, you are saving the same file. One message will come, no? Right. You want to replace the existing file or you want to skip it? One message will come or not now? The same. Whenever I given a memory for M, came from the parent, I want to give the memory for child class method. I want to give a memory for child class method. So it will come and replace it. No, it will not ask any message here. it will come and replace. Means what? Already one component is there. Again, you are copying the same component, or again, you are giving the memory for the same component. So definitely you should replace, sir. In your operating system also it is replacing. It should replace. So what happened now? This method will be replaced by your child method. Void m of int x replaced by child method. This is child class method. Replaced or not now? This is replaced. So replacement happened. Understood the replacement, everyone? That's called replacement. So that only we call it as a method override. You can say this method has been overridden. It has been replaced. Once it is replaced now, this address will be loaded to OB. That's called overriding. You can call, whenever you call now, ob dot m of, I'm calling not 12, m of 12. Now, only one method available there now. Only one method is there now. I'll call this method. And this m method will come out. So child class method only will come out. So parent class method already replaced. Void m of int x. Child class method already replaced. That concept we call it as overriding. So answer is from child class method. The answer is coming. Right. All of you understood this diagram? Says or no to me? Right. It's called replacement. This method frame destroys and this one. Because the answer is from child class method. Means what is overriding now? The method with the same method signature in parent class and child class. Then parent class method is replaced by child class method while object creation. The replacement happens while object creation is known as method overriding process, or you can say method replacement process, you can say. All of you understood this? Right. Okay. Now, this is a diagram. Now, sir, anyway you done instance method overriding you done. This method is instance method. Sir, what about static method overriding? Make it FAQ. I want to do static method overriding process. Static method overriding process. Define static method overriding process. Right. Now, static method will get the memory within the class or within the object? Within the class. When the static methods are available within the class, static methods will not come to the object. When the static methods are not coming to the object, overriding not available. So, static method overriding process is not available. We can say we cannot perform static method overriding process. Simply can say there is no concept. There is no concept of static method overriding process. there is no concept of static method overriding process. There is no concept of static method overriding process because static methods will get the memory within the class. There is no concept of static method overriding process because static methods will get the memory within the class and available within the class. Available within the class. So they are within the classes only. They will not come to objects. So overriding will not happen. That's the meaning actually. Look here. Suppose the same program I'll do with the static. Same program I'll do with the static for comparison purpose. So inheritance application 3 I am taking. Inheritance application 3 I will take it. Same program, I'll copy it. Above same program, I'll copy it. Demo inheritance 3. Right. Parent class, child class, demo inheritance. This method is static. Static. Overriding not available. Overrided. This is not override method because static that is. So system dot out dot println. Here I am printing from parent class m of x. I'm printing. Now system dot out dot println the value x is equal to plus x. In the child class, see overriding not available. Override P1. This instance method cannot override static method for parent class. Overriding not available. Take it as static. This is static. So this is static. Two static methods I taken. For static method, object creation not needed. No, yes or no. Na. You can call with class name directly. Child class dot m of some 123. The answer will come. The answer is coming. But the answer is coming from the child only. You observe, right? So let me draw one diagram for visual because you know I'm not creating object. The methods are in the class. For visual, I'll write. Now, side by whatever the diagram I drawn today, the side by. Yesterday's diagram, I'll close it. Today's diagram, side by I'm drawing here, side, for comparison purpose. Now, method area where classes are loaded. Heap area where objects are created. Where methods are executed. So, method area, heap area, Java stack area. Now, anyway, main class will be loaded and main method will come for execution. Main method will come for execution. In this main, I written child class dot m. Like this, I written like this. Now, now parent class running or not, child class running or not, I want to know, sir. I'll write one static block here. One static block is there, no? Right, one static block. So static blocks are running, no? Right. That is separate discussion. Anyway. Okay, right. So means what? Parent class also loading, child class also loading. Understood is fine now, right? Okay. So the just the information is parent class also came. That's the information. Okay, right. I'll remove this static block discussion separate. Because still we not entered into blocks and constructors. Still we are with methods only. Still we are with methods. Okay, right. Now, our diagram is child class M. Your execution engine will see that call method M which belongs to child class. Call method M which belongs to child class. Now your execution controls will pass message to class loader subsystem to load child class. Now the child class must be loaded. But in inheritance process, who will be loaded first now? Parent. So parent will be loaded first. So this parent class is coming first. Parent class is coming. You know, no? While class loading, static members will get the memories. While class loading, static members will get the memories. Parent class static. M is there, no, here? Right. The method M will get the memory here. The method M means void M of int X will get the memory. Once the parent class loading completed, then the child class will be loaded. Y line. Child class will be loaded. Child class will be loaded. Now, child class also have one method, no? M method is there. So, this method will get the memory. Void M of int X. Body. So, what you observed here now? Sir, parent class method got the memory in the parent. Child class method got the memory in the child. Where is the replacement? Not there. So static method override not there. Because override means replacement. No, both got the memories no already. In the previous diagram, who got the memory here? First parent. The memory is replaced by the child, no? Finally, who is having the memory now? Child class method only having the memory. But here, both are having the memory, no, sir. So static method override not available. It's a concept. Now, once the loading has been completed, it looks like a single class only. Just now I made a statement. It looks like a single class only for execution engine. Right. But here, even it is a single class also, whenever it want to access a method, it will access child class method. First, it will look into child class first. Means internally, both are visible like a single class only, but internally separate. Example, whenever you construct one house, whenever you settled with good job, you'll construct one house. Whenever you construct, one house number will come. That's called child house, means you construct it. But you will call your parents and you'll make them to stay with you. Whenever you will call your parents and make them to stay with you, you'll give a separate bedroom, no? You'll give a separate memory or not now? You stay here. I'll stay here. So that address belongs to child only, roughly I'm speaking. That location is child, but parent, you sit there. Child, I'll sit here. You are part of my house only. Your house number is my house number now. When I am a kid, my house number is your house number. Parent house number. Whenever I settled, your house number is my house number. Means what? My address is your address. Child address is parent address now. That's a concept. But whenever you want to access it, here, it comes to child compartment first. Child, that is, algorithm says that I'll go to child. Means what? The algorithm will come to child first. Child location, it will come. Whenever in the child location, the method is there, the method will come out. This method will come out. The algorithm says that I'll take the method from the child. Void m of int x. It will come from child. I'll come from child. So child output will come. Child class output will come. Just now, child class output is coming or not? You can see. Understand? Sir, if the method is not available in the child, suppose you are calling from child, in the child class, I removed this method. In the child class, I removed this method. In the child class, method not available means the method will come from the parent. Have you observed this point or not? No. It comes to the child, not available means parent. So what you observed here now? Sir, parent method ready for execution. But execution engine is not reaching that method. Parent method is ready for execution. But execution engine is not reaching that method. This concept is known as method hiding process. What is the process name now? Method hiding. Which method hidden now? Parent class method hidden by child class method. Same method signature instance method overriding. Same method signature static method hiding. Write it. FAQ. Define method hiding process. Define method hiding process. Define method hiding process. Method hiding process. Right. Same static method signature. Same static method signature. in parent class and child class is known as method hiding process. Same instance method signature in parent class and child class, that is overriding process. Same static method signature in parent and child is known as method hiding process. Make a statement. Same static method signature. Same static method signature. Same static method signature in parent class and child class. Same static method signature in parent class and child class is known as method hiding process. Method hiding process. Same static method signature in parent class and child class is known as method hiding process. Here hiding meaning is cannot reachable is known as hiding. Generally, look here. Roughly I'll speak always. So A is one person. Always I'll speak this. B is one person. Now I can say B is hidden and A is finding him. Whenever you say the A is trying to find B, when you can say B is hidden means when A cannot reach B. Nothing but cannot find B. Means you don't know where he is. Means you cannot reach. When you cannot reach, that is hidden. So in this diagram, execution control is coming to child class method, but it is not reaching parent class method. It cannot reach this parent class method. It cannot reach. Why it cannot reach? Because same method already available, no? Same method already available in the child, so you cannot reach. So this method, we call it as hidden method. This one, we call it as hidden method. All of you understood the statement what I made to you? This is hidden. Right. Make it same static method signature in parent class and child class is known as method hiding process. Note, supportive point for reading purpose. The execution control cannot reach parent class method. Cannot reach parent class method because same method signature available in child class. The execution control cannot reach parent class method because same method signature available in the child class. And which is known as method hiding process. In bracket, parent class method is hidden by child class method. Hidden by child class method. Right. Left and that? Right. FAQ. Can we access static members using object reference? Can we access static members using object reference? Static members are in the classes, objects are classes. But the question is, can you access with object indirectly? Yes or no now? By spelling. Where is the spelling? Look here. Now, in this program, I had object. I am creating object using object. So I am creating object. Using object, I am accessing. Whenever I access with object, the answer will come. Answer is coming or not now? So we can access. Sir, if you create object, what happens, sir? I want to know. See there. First, I'll draw the diagram. So I am creating object. I am creating one object. Child class OB is equal to child class OB is equal to new child class. So create object for child. Object means one address, no? Right. One address created. 0x2. Now, while object creation, instance members must come from parent. In parent, instance members not there. I want to take instance members from child. In child, instance members not there. So, no memory is created here. If any variables are there, if any methods are there, in an instance, I'll give a memory. Nothing is there. But one address is created. But one address is created. This address belongs to the class. One address created, the address belongs to class. This reference, by terminology, we call it as empty object reference. Is known as empty object reference. EMPTY, empty object reference means no members available. But even then, you can access. How will access now? See there. OB.M of 12. Now, OB.M of 12 means access the method from OB. We are looking into OB. In OB, M not available. Whenever not available, go to the class. When not available, come to the class. The reason, this address belongs to this class only. If it is not available in the child, then go to parent. That's the meaning. Means what? We can access static members using object reference variables because the objects are generated from the class. Maybe memory created or not created, but the address is created. The address belongs to class only. You can access. Make a statement. The answer is yes. Yes, we can access. We can access static members of class using object reference. Object reference. Because the object reference belongs to class. The object reference belongs to class. It is created based on the class name only. It is created. Yes, we can access static members of class using object reference because the object reference belongs to class. But in that diagram, I commented it as empty object reference, I said. In your diagram, I commented as what now? Empty object reference. Interview question is there. Define empty object reference. One interview question is there. FAQ. Define EMPTY. Empty object reference. EMPTY, empty object reference is created. Empty object reference is created. Empty object reference is created when we create object for the class. Empty object reference is created when we create object for the class holding only static members. Empty object reference is created when we create object for the class holding only static members. Only static members are there. If we create object, the object will be empty. So address will be there, memory will not be there. That is known as empty object reference. All of you understood this statement? Right. So this diagram I'll post to you as a hided method. So here, if you look these two diagrams, same program only, these methods memories are not available here. Memory is here, but here, this is overriding. This is method hiding. One diagram is overriding. One diagram is method hiding. Here, method overriding process. Overriding process. Method overriding process. Here, method hiding process. Here, method hiding process. Here I'll add this program today for you. So example, P1 I took parent class dot Java. P1 I took child class dot Java. P2 I took demo inheritance 3 dot Java. This is one main class, and the output will come from your child class only, because I used object also there, followed by diagram. The diagram. So how to remember now? Summary. How to remember it? Make it summary. 2 points here. Same instance method signature. Same instance method signature in parent class and child class is known as method overriding process. The same instance method signature in parent class and child class is known as method overriding process. Same static method signature in parent class and child class is known as method hiding process. Method hiding process. The concept. Done it? Okay, right. Now see. Now comes FAQ. Define generalization process. Define generalization process. Define generalization process. Look here. So since yesterday, we are doing one inheritance. So one class we are taking. So P class, one class. We are taking one more class. C class means child class. Class. Here to here, we are linking. Extends. Here I'll take one method. Void M1 of int X. I'll take it. So void M2 of int Y. I'll take it. Void M1 of int X. Overriding void M3 of int Z. So which one is overriding method now? This is overriding method or not now? Right, okay. So now if I create object like this, so child class OB equal to new child class. So this is normal inheritance process. Normal inheritance process. Normal inheritance means one object created. The object will hold M1 as a overriding, M2 and M3. This is. But parent class OB is equal to new child class. We must write. We are writing parent class OB is equal to new child class. We are writing. Whenever you write parent class is equal to new child class, the object created for child, but internally generated as a parent. Means object looks like a parent object. So this concept we call it as generalization. What is the name of this now? Generalization. This is generalization process. In generalization process, one object will come. See there. Child class OB is equal to new child class. You understood no yesterday diagram? Right. So today parent class OB is equal to new child class. Parent holding the address of child class object. So the child class object also generated as a parent object. Understand now? That is concept. This concept we call it as a generalization. Here, what happens? One object created holding all the members of parent class and overriding members from child class. Only overriding members from child class will come. Overriding members means which one will come now? M1 will come, M3 will not come. Make a statement. Make it. The process in which one object created holding all the members of parent class. The process in which one object is created holding all the members of parent class and only overriding members from the child class. Overriding members from the child class is known as generalization process. The process in which one object created holding all the members of parent class and only overriding members from the child class is known as generalization process. We use the following syntax. To perform generalization process. We use the following syntax to perform generalization process. Parent class OB is equal to new child class. In interview, they'll ask this question. Child class OB is equal to new child class. Everybody will read because they'll ask this. Draw one box for it. Today one assignment question I'll copy in your document. Okay, right. So anyway, concept is going on. One question I'll give it. Yesterday I given references, no? How many of you tried references completed? What assignment I given on Saturday, no? Saturday na? Yesterday na? Saturday only, no? I given one question. How many of you completed? References. Not completed? Right. Today I'll give one question on inheritance. Right. So let me try this once. Inheritance application 4. Inheritance application 4. Package P1. package P2. Under P1 again I am taking P class. I am taking C class. Under P class I am taking method M1. Whatever I drawn there, that only. Void M1 of int X I am taking. Now system dot out dot println the parent class M1 of X. Now system dot out dot println the value X is equal to plus X. Like this. One is M1, one is M2. Not only drawn the diagram M1, M2. Now, child class extends from parent class so anyway child class overriding child class M1. This is child class. This is M3 of Z. This only overriding and this is non-overriding. Anyway, one is overriding, one is non-overriding from your parent. Look here. Here, overrided method, non-overrided method. Means two methods are there in parent. I am overriding that method and this is not overriding anybody. Okay, right. Now create your generalized object. Go for P2. Demo. Inheritance. Demo inheritance 4. I am taking. Import P1 dot star. I am taking generalization process. I am taking. Generalization process. Parent class OP equal to new child class. Here OB dot M1, because M1 belongs to parent, no, it will come. OB dot M2. M2 belongs to parent, no, it will come. OB dot M3, it will not come. Because M3 is non-overriding, it will not come. So parent class methods only will come. Parent class methods only will come because the address belongs to parent. Child class non-overriding method will not come. If you run it, parent class method overrided from child and came. And child parent class M2 came. Parent class M1 overrided and came. But non-overriding method M3 not coming. So the only statement. One object created holding all the members of parent and all the members of parent and overriding members from child. Not only concept of generalization. Right. Before drawing this diagram, anyway, I'll show the diagram also. Whenever the generalization is there, write it. After that syntax, write. Have you drawn that box? P class OB is equal to new C class. Draw one box. Right. In generalization process, object created for child class. In generalization process, object created for child class. In generalization process, object created for child class. But internally, parent class object is generated. In generalization process, object created for child class, but internally parent class object is generated. Means child class object converted as a parent class object. That's the meaning. In bracket, child class object converted as parent class object. Object means memory. The memory of child at looks like a memory for parent. That's the meaning actually. So whenever the generalization is there, one more will be there. Specialization, one more key. Specialization means reverse. Here, child class OB equal to new parent class. This is specialization. But here, when you are coming from parent to child, when you are coming, you have to convert manually. So child class you must write. This is syntax. You are converting parent object into child object. You are converting. Here child object into parent object. But here parent object into child object. This syntax we call it as specialization process. Specialization process. Specialization process. Right, make it. FAQ. Define specialization process. Define specialization process. First, you must know the definition of specialization first. Definition of specialization, like this. Suppose engineering is one stream and it's like a parent. It's like a parent class. Sir, from that engineering, some students will be specialized in AC. Somebody will take specialization mechanical. Some people will take specialization as a civil. Like this, we are taking the specializations. Specialization means taking one and being a specialized person there. Some people will be there, no? Sir, morning Python, sir, afternoon Java, sir, evening .NET, sir. That is not specialization. Some people will attend. Why means freshers you can attend. But when you come to career, only one will be there. Career different, learning different. Career will be one only. Sir, I know Python also, sir. I know Java also, sir. I know .NET also. Means you cannot work in 3 companies at a time, no. So early morning Java, sir. Afternoon .NET, sir. Evening Python, sir. Not possible. Specialization means one only. Like us. Some people are there, like me. We are branded with Java since many years. Other thing you ask also, we don't know. You ask a question in C language, I don't know. Ask a question in Python, I don't know. What happens also, we never see. Uploading notes only, time not there. 1-2 times I'll delay it. The reason behind that also there. Suppose after leaving the class, if you can upload, if somebody asks the question, 5 minutes will go. My system has to move to another block. So they will close my system and next batch is a new batch, I think, Django. So they'll ask me to close bit early because the students will come inside. Because sometimes I load, I'll forget it. I will not load, I'll think it. Next batch is 11 AM advanced. Almost 350 people will come for that offline only. So that more doubts will be there for them. Advanced Java. So after the class completed, they'll ask 1 or 2 questions. It will be a 110, 115 will happen. Again, 2 o'clock batch is there for me. For me, 55 minutes time will be there for lunch. So if I keep on editing the notes, again 20 minutes will go. I must travel to home and come. I'll close the system. Again 2 o'clock batch, 4 o'clock batch, 6 o'clock. If I'm in the good mood, I'll upload it. If I'm irritated, I will not open the laptop. Already 12 hours will see the laptop. No, that irritation will be created. That is the reason 1 or 2 times we'll never load it. That time only not there. How can we look into another subject? Python, what is happening? We don't know. C language, recently what happened also, we don't know. Older things we know. So that is called specialization. Specialization means only one. In this biggest hub of Amirpet, I'll take one. I'll be the master in that one. That is known as specialization. The process of taking one feature from the parent and constructing the child class is known as a specialization. Means from parent, n number of features will be there. Features means methods. Taking that and constructing the parent, constructing the child. That concept we call it as specialization. Engineering is the biggest stream. I took EC, that's all. You are specialized as a EC engineer. No, sir, I took 2 branches, sir. EC and mechanical, not possible. Morning EC I'll go, sir. Evening mechanical, not possible. You have to take only one. That concept we call it as specialization. Your other said, you can, instead of taking all features, second case, I'll take all features from parent, from the child I'll take override. That is second one. Third one, take only one. Any one. And construct the child. That concept we call it as an specialization. Make a statement. The process of taking one feature from the parent class and constructing the child class. The process of taking one feature from the parent class and constructing the child class is known as specialization process. The process of taking one feature from the parent class and constructing the child class is known as specialization process. We use the following syntax. To perform specialization process. Child class OB equal to child class new parent class. Draw one box. Right. Here one coding rule you have to follow. Right. Coding rule. In specialization process, in specialization process, in specialization process, the parent class must be predefined class from the library. In specialization process, the parent class must be predefined class from the library. That is a rule. So parent class must come from library. Else raises. Else means if not. Else raises java dot lang dot class not found. Sorry. Class cast exception. Exception means a disturbance. In specialization process, the parent class must be predefined class from the library. Else raises java.lang. Class cast exception. Underline that. Java.lang. Class cast exception. If you don't follow the coding rule, that exception will come. Disturbance will come. Right. Now look here. Look here. Here, generalization is there. Answer is coming. I am doing specialization here. Specialization process. Specialization process means child class OB2 equal to child class new parent class. So syntax error not there. But here parent class is not coming from the library. Parent class is a user defined class. I not followed the coding rule. So disturbance will come. What is the exception now? Class cast exception. What are the rules of specialization now? Parent class must come from library. That's the rule. Specialization separate unit. Here because of syntax I written here. Make it here. Example of specialization process. One is cloning process. Cloning process is an example of specialization. serialization process is an example. So serialization process. These two processes are examples of specialization. Both are units to you, separate. Okay, right. So generalization, I'll draw the diagram, specialization separate. But why I written the notes here means you must know 3 syntaxes available. You must know 3 syntaxes available in inheritance. You can write child class, new child class, your parent class, new child class, new parent class. So 3 syntaxes available. The student should know for interview. So generalization anyway, overriding methods will come. The diagram I'll draw. So specialization, separate training. This one already diagram is there yesterday for you. Okay, right. So this is the program I'll keep here. So example P1 I'll take parent class dot Java. P1 I'll take child class dot Java. P2 I'll take demo inheritance. Demo inheritance 4. So one diagram I'll paste here. So whatever I drawn here, I'll paste this. This one, this diagram is there, and I'll paste in the last for you. 3 syntaxes available. This generalization diagram I'll draw tomorrow to you. And today you'll get one assignment also. One assignment through document for you. One assignment question will come through document. I'll upload the document in the Google Classroom. One question only, one small question, you try it out. So today you must try that assignment. Already references one program solution you're waiting, and this program you must try today, tomorrow. You try that. Tomorrow, day after tomorrow, after inheritance completed, then I'll give the solutions. So plan. Okay, right. All of you comfortable for today's class? Right. Okay. So read the notes and come, everybody. So I'll upload the notes now. Right. Take a break. Thank you very much for today.